Namaste and good morning to you all, and also welcome to another session of online mathematics class. In the previous sessions, we have learned about some basic metric operations like matrix addition, matrix subtraction, matrix multiplication, and also we have learned how to write the transpose of a matrix. And also in the last session, we have learned how to write a matrix as a sum of symmetric and skew symmetric matrices. Hope you have revised all these concepts well and also updated your notebook. Today, we will learn about the elementary operation of a matrix. The elementary operation of a matrix. Let us have a quick look about the elementary operation. What we mean by elementary operation of a matrix. The idea of elementary operation find its relevance when we are operating the coefficient matrix. When we are dealing with the coefficient matrix means the matrix formed by the coefficients of linear equations. The idea is that if we apply these elementary transformations on the matrix, after the application also the solution of the equation will not change. Means whatever the solution used to get in the original matrix, we will get the same solution with the transformed matrix also. So let us have a quick look about the elementary operations. The first operation is the interchange of any two rows or columns. The interchange of any two rows or columns will not affect the result of the matrix. For example, if we want to interchange R1 and R2, the representation is like this: R1 interchange to R2. See, we have a matrix A is equal to 1, 2, 1, minus 1, root 3, 1, 5, 6, 7. And we will have row 1 here, and we will have row 2 here, and we will have row 3 here. And R1 interchange to R2 is our operation. When we do R1 interchange to R2, what will happen to the matrix? Let us have a look. R1 and R2 is interchanged. See, for example, R2 came to R1 position. See, R2 minus 1 root 3 1 came here in the first row. And R1 came to the R2th position. See, 1 2 1 here came to the second row. R1 2 1. And the third row we have nothing applied here in third row, so it remains unchanged. 5 6 7 is here in third row. Here also 5 6 7 in the third row. So this is the first operation. See, for example, R1 interchange to R2. If we interchange any two rows, the result will be like this. And to move on to columns, see, for example, here C1 interchange with C3. Column 1 and column 3 interchanged. Let us have a look at the matrix here A, and we will have C1, and we will have C2, and we will have C3. And we are interchanging C1 and C3. We are interchanging C1 and C3. C1 will come to C3's position. C3 will come back to C1's position. So let us have a look. A is equal to C3 change to C1. See here, 3 1 1 represent here C3. That came here as C1 3 1 1, and nothing mentioned about C2 here. So C2 remains the same, 2 1 1. Here also 2 1 1. And C1 came to C3's position. So C1 1 4 2 is C1 here. It came here as C3 1 4 2. So this is the first operation, interchanging the rows and columns of a matrix. Hope it is clear. Now move on to the second operation, that is the multiplication of the elements of any row or column by a non-zero number. The multiplication of the elements of any row or column by a non-zero number. For example, we are having a matrix B is equal to 1 2 1 minus 1 root 3 1. Here, multiplication of the elements of any row or column by a non-zero number. Here I am taking a column C3, And what I have done is C3 just multiply 1 by 7 with C3. Multiplication of the elements by a non-zero number. So I have taken C3 column 3 and I have multiplied 1 by 7 with C3. So we will get the matrix as first column remains same, 1 minus 1 remains same, second column also remains same, 2 root 3 that also same, but the third column here you see 1 1. I have done the transformation here. I have multiplied 1 by 7 with the third column, so I have to change 1 into 1 by 7, it is 1 by 7, 1 into 1 by 7 here also 1 by 7. The third column is changed, 1 by 7 and 1 by 7. So the general form of representing the multiplication of elements of any row or column by a non-zero number is Ri. Any row we can multiply with a k. K is a scalar quantity with Ri, and Ci change to k into Ci. Here k not equal to 0. K must be a non-zero number, and this is the general representation of the transformation. We'll move on to the next elementary transformation, that is the addition to the elements of any row or column, the corresponding elements of any other row or column multiplied by any non-zero number. If we go through this sentence, we will have a little bit of confusion. So what we have to do is, let us take an example. Through the example, let us try to find out what does it mean. So here I'm taking an example. Matrix C is equal to 1, 2, 2 minus 1, 2 by 2 matrix, and we will take an operation R2. Here row, I'm considering row, so row operation it is. So I'm taking R2 changes to R2 minus 2R1. Means here what it is saying is, you multiply a scalar with any row or column. I'm taking here row, I multiplied a scalar 2 with row 1, and I add or subtract with any row or column. So here what I have done is multiplied a scalar 2 with R1 and I subtracted that one from R2. Once again, multiply a scalar with R1 and I subtracted from R2. This is what the operation. So let us have a look at that answer. We will get here 1, 2, 0, minus 5 as the resultant matrix. See, for example, here it is mentioning about R2 only. Okay, R2 only changing, means R1 has no change. So same 1, 2 will come here as R1. Now R2, each element you have to take and we have to do this operation. R2 first element, see, look at this 0, how we have got 0. R2 first element is 2 minus the scalar 2. Here this 2 is coming here, 2 into corresponding element is here row 1 element, that is 1. Corresponding row 1 element, that is 1, it is multiplied here. 2 minus 2, we have got the answer 0. Now how we have got this minus 5, let us have a look. So here first element, that is minus 1 here, second minus 1 we have taken here, secondly, then minus 2, the scalar is here, 2 into corresponding first element, that is this 2. So will come here as 2. So minus 1 minus 2 into 2, that is equal to minus 5. That is the way we have got this minus 5. In general, we can write this operation as Ri changes to Ri plus k into Rj, means multiply is any scalar with any row and add or subtract with any other row. Same operation is for column also. Now let us have a quick recall about some of the basic concepts, some basic questions. 3 multiplied by what will give us the answer 1? I repeat, 3 multiplied by what will give us the answer 1? Answer is quite simple, that is 1 by 3. Again, what multiplied by 5 will give us the answer 1? Answer is simple here again, that is 1 by 5. Here 1 by 3 and 3. 3 and 3 cancelled, will get the answer 1. 5 and 5 cancel, will get the answer 1. So this 1 by 3 and 1 by 5 are called the reciprocals of the respective numbers. So when you multiply a number and its reciprocal, we will get the answer as 1. In case of matrices, we know that 1001 represents an identity matrix represented by the letter I. This is an identity matrix of order 2. Now, a matrix A is multiplied by what will give us the identity matrix? A matrix A multiplied by what will give us an identity matrix? According to this concept, we will directly tell that it is 1 by A. But in case of matrices, 1 by A reciprocal of a matrix is not defined. So here we will represent it as A to the power minus 1. A into A to the power minus 1 is equal to I. Again, what multiplied by a matrix A will give us identity matrix. Here also A to the power minus 1, and these A to the power minus 1 are called the inverse of a matrix. There is a representation of inverse of a matrix, and today we will learn about the inverse of matrices.